So here is our flowmeter project which we developed. So basically this has the 3D printed parts. So this is the casing, there is the top casing as you can see, and the button magnet mounted onto the plate. This is also 3D printed. So we have used RepRap Athena 2 for the printing. So let's talk about the casing first. So this has the casing, and inside it's hollow and it has the blades. So basically when the water impinges on the plate, it rotates and in turn rotates the bearing, and this bearing would be having the button mounted sensor which would be going onto it and would be rotating. So let's see its demonstration. So we have not tightened our casing, just to let you know like which part is exactly rotating. So as you can see, the bearing is rotating here, and based on this it is rotating the button mounted part. Now we'll talk about the electronics part and we'll come back to our desk.
So on top of it, the button magnet will go. As you can see, this button magnet will go on top of it, and this button magnet will be detected as a pulses by the Hall effect sensor. As you can see, this is the Hall effect sensor which has three lines coming from it, and this is the one that will detect us with the pulses. As this button magnet will rotate around the bearing, and that will be detected as pulses. So this the Hall effect sensor, as we can see, is giving a digital input to the Arduino board, and this Arduino board will calculate the total flow coming out of it. So the as we found that with one rotation of the blade inside the casing, it gives nearly 50 ml. So we took one pulse as 50 ml, so the total flow will be calculated on the basis of number of counts that is being detected, and this will be essentially be displayed on the LCD. So this Arduino, this Hall effect sensor will be mounted on top of it, and the casing will be coming on top of it. So this will come out as an integral part, and the total flow will be detected on the LCD. That's it from the team. Thank you.
Thank you.